We're going to talk about your wireless network. It's something that you may not think about at all. And in fact, if it's working well, that's awesome because networks are great when we're not thinking about them because that means they're working. But I do want to make this visible to you, what your wireless network is. Now, when I refer to wireless, I don't usually say wireless. I'll say Wi-Fi in polite mixed company. But I'm really talking about 802.11x, with X standing for different flavors of Wi-Fi that we'll talk about in just a moment. The reason is that this is the actual specification for using radio technology to transmit data signals. And it's a very specific term. If you've got a mobile phone, you can start counting the different wireless technologies that you're operating in that. You've got the cell phone network, you've got Wi-Fi, you've got Bluetooth, you probably have near-field communications, which is a different sort of short-range wireless connection. There may be more that I'm not thinking about, but that starts to become a lot of wireless connections that are actually very different. So we'll say Wi-Fi, or I'll say 802.11x, and the X stands for different things depending on the generation of Wi-Fi. Wi-Fi comes in flavors, and I want to thank Monica, my wonderful assistant, for finding this incredibly great image of different flavors, because if you look closely you can see that those are balls of yarn, and of course when I look at that I don't think about knitting, I think about different colors of network cable. I'm a geek, sorry. So I love this image, and I hope you do too, because I think it's like super cool. The earliest type of Wi-Fi is 802.11a, and at the time that it came out, it was capable of 5 megabits per second. That was the speed of 802.11a. Now, A is actually still with us, and the speed has increased to 54 megabits per second. It's just not a commonly used protocol, even though it's supported in a number of places. If you are looking at your stuff and you say, hey, we don't support 802.11a, it's okay. Don't worry about it. Some places do, some places don't, but you don't need to worry about that because it's just not commonly used enough for you to worry about. 802.11b was a faster connection to the internet, more than doubling to 11 megabits per second as its capability. Now I want to take a little sidebar here about the capability of Wi-Fi systems. 11 megabits per second is the theoretical maximum a speed that can be connected, but there's other factors that influence connection speed. One is how close are you to that antenna? How close is your Wi-Fi device, your laptop, your cell phone, your tablet? How close are you physically to the antenna, the Wi-Fi access point? The other is how many other people are also connected. All of those factors come into play when it comes to what's happening in the actual speed. So no one ever really gets as fast of a Wi-Fi connection as advertised, just because there's other factors involved. So just use that as a guidepost for you when thinking about different Wi-Fi speeds. But 802.11b is the next. Any guesses what happened after 802.11b? We first had 802.11a and then B. What's next? C? No, G. G was even faster than B, and now you're scratching your head and you're going, great, it's faster, but what about all those missing letters? Our standards organizations are always working on what are called draft standards. These are different versions of the standard. The reason for the standard is so that manufacturers can be all on the same page on defining how a piece of equipment operates, so that that different pieces of equipment can operate together, so that they can be doing the same thing. 802.11g was a standard. I'm sorry. Sometimes earlier standards are never adopted, and standards farther along into the future are the one that are saying that's the one that we're going to bless and allow to be called a standard and allow people to use. So that's the reason for the gap. So there's A, B, and then G. And G is really, really fast, or faster, up to 54 megabits per second. It's also when many of us first became aware of Wi-Fi because it was also becoming affordable. There was a mass market push to get this out into the community. It was becoming more affordable to make Wi-Fi devices and Wi-Fi access points. So for a lot of us, a G access point was actually our first Wi-Fi connection. After G, there's another break in the alphabet going further in. There's the N specification, and N is really, really cool because not only did it get faster in its capability, but also there was the thought of using more than one antenna in a Wi-Fi access point. Having more antennas allows for more simultaneous connections. So that's one of the ways that capacity and scalability was starting to be built into the specification for Wi-Fi. Really cool, right? Speed could get up to 100 megabits per second. Our current fastest standard is 802.11ac. So now we're getting into doubling up the letters. Isn't that even more confusing? I hope it's not. I think if you think back and just think about the sequence of the alphabet, and then when you have 802.11 followed by 2 letters, it's getting even faster. Hopefully that will help you remember the different speeds. This is really, really fast. It also fast with today's speed. Everything's relative, right? It also really supports many simultaneous connections, multiple antennas. You might wonder, why is this needed? Do I need AC in my library? I don't think you need AC in your library right now. My thought is that the reason that AC access points, and they're expensive, they're in the $300–400 range sometimes for an AC access point, is for home users. We are streaming more things in our home that take lots and lots of bandwidth, including video, including games and gaming. More of our devices need faster connections, and we have more and more devices in our home that need to support this. So we see a lot of growth for AC access points in the home. I'm not sure that we need them in libraries at this point, but maybe in the future as capacity goes up. If you want to get an AC access point, go for it, because the standards also tell manufacturers that they have to be backwards compatible with earlier versions of the standard. So if you're able to get an AC access point, go for it, because it most likely also has more powerful computing devices inside of it. It's just faster processor, more memory, more efficient in the way that it handles signals. This is a chart for you to look back at just as a reference for the different Wi-Fi flavors. And now I want to talk about an SSID. That stands for Service Set Identifier, and it's simply what we call our Wi-Fi access point. So a lot of times we might see something when we go into a library called Library Wi-Fi, and using our device we connect to it. That is the SSID. So you might even want to take a moment and familiarize yourself with the SSID that you are using right now. In terms of Wi-Fi security, we're going to talk about 2 passwords at this point. 2 passwords that are important, and they have different significance. For our staff connections to Wi-Fi access points, they should always be encrypted and require a password. Encryption scrambles the signal so that it can't be eavesdropped upon, that other people cannot monitor those communications or read them while they're being done. That is what we commonly use for staff networks. We commonly do not use that on public networks for good reason, because we want our public networks to be friendly and accessible. So we handle security in a little bit different way for our public networks than our staff networks. But that's one level of password. Another level of password is what we use to actually log in to our Wi-Fi access point, our router, to make configuration changes. It's very important that we do have a password for that application, because we don't want anyone messing with our stuff, right? We don't want people changing that very, very important connection. So that is the other place where we'll be referring to a password in terms of Wi-Fi. This is a picture of the consumer-grade Wi-Fi access point and router that we used in our class, and it's super cool because it's got all the functions in a small form factor. This might even be one like you have in your library. Many libraries use equipment like this. It has different ports on the back. wireless needs wire to function. And so there's two things that are important to us. The port that is yellow on our unit says internet. It also could be called a WAN, or a wide area network port. That's the port in our diagram that faces up, that goes to our internet service provider and ultimately to the cloud. The blue ports are the ports that go down on our network diagram. Those are the ones that feed our Ethernet networks, provide the access there. But all these ports, this is an area where it can be kind of confusing, because those blue ports on our router are called Ethernet. Technically, all 5 of these ports are Ethernet. That's the technology it uses, but they have different functions, of course. So it's important the way that they're plugged together. We talk really briefly about this. This is mainly for your information to know that there's different ways of authenticating users, and sometimes it's called something kind of geeky, user authentication. There's also device authentication capability built into our networks. That means that we allow or disallow certain functions based on something called a MAC address. It's one way to do it. There's many, many different ways to control the devices on a network, but there's one that we want you to know about. It's called the MAC address, and that stands for Media Access Control. It's a different series of numbers expressed in hexadecimal, separated by colons. So it's 2 characters, a colon, 2 characters, a colon, and so on. You may have devices in your possession that actually have the MAC address printed on them. Our a router for the class, for a class, actually has the MAC address printed on the underside of it. If you have a non-Apple cell phone, you can pop the battery out of your phone, and you will probably see a MAC address there. There's a unique MAC address for every network connection that a device is capable of. So if you have a device with a wired and a wireless connection, each one of those connections has a MAC address. And it's a way to identify an individual device, because there's no 2 MAC addresses that are alike. It is possible to clone MAC addresses or to spoof MAC addresses, but it's not something that we encounter too often when we're thinking about our security options for libraries. So I want to let you know that nothing's foolproof. I'm sorry to say that, give you that news, but that's something also that should go into your thinking, that when we're looking at different ways of controlling our networks or our devices, that there's often many ways to do this and many layers that add up to security. In big places, it's hard to do onesie twosie sorts of device control when we're setting things up, and I just wanted you to know that if you've been thinking about that, there are different ways that we operate in an enterprise. And when we say enterprise, that means like a big place with lots of data, lots of connections, lots of devices. And one of the ways that we do that with Wi-Fi is we don't ask that Wi-Fi access point to do all of the heavy lifting in terms of security. What we'll do instead is use something called a radius server, which would help authenticate the user to be allowed access to that network. So it's the cop at the gate saying, "Yep, you can get in," or the bouncer. Maybe the bouncer is a better term. The bouncer bounces off people that are not supposed to be there because they're not awesome enough, and or they're not nice enough, and they let the good people in that should be allowed within that network. Wi-Fi security and encryption is a big topic, and not something that we want you to be mystified by. It can be complicated, though, because the way excellent, powerful encryption works is based on the power in prime numbers. Don't go to sleep, because a lot of people, when we did this, were like, "Oh, prime numbers, great." Just what I wanted to think about, because we had this segment of the class after lunch. We found an excellent, wonderful video that actually, in a very short time span, it's less than 5 minutes, explains what that little lock that you see when you see the encrypted connection when you're logging into a site, maybe a site where you're using your credit card or you're putting personal information. This explains actually how that works. So we want you to take a few moments when you can and view that video. I promise it will be painless, and we have the experience to prove that, and I also think it will give you a higher level of confidence in how security works. When you're thinking about your own Wi-Fi security in your own library, again, not necessarily in terms of your patron connections, but your staff connections, not all of it is as powerful as that video shows. Earlier versions, especially WEP, is crackable and breakable, and nobody even has to have skills to do that. They can use scripts, and they can use automated ways to break it. No modern Wi-Fi access point is going to allow you to use those older ones. I just want you to be aware that there's different levels of security, and that you should be using the strongest one that's available to you. In most cases, that's WPA2 in your routers. We have open public Wi-Fi, and I've been saying that that's what we want to do. The idea of the openness makes it easy for people to connect. Sounds simple. It sounds almost too simple, but think about how frustrating it can be when you're not able to connect to things easy. We rely on that encryption in that other video that describes that. We rely on the encryption of service providers like Google, like Amazon, any place that someone's going to interact with electronically in a place where we want the data communications to be secure. We rely on them to provide that heavy lifting, and that actually allows us to be more open in our Wi-Fi access points. Having encryption in our access points actually also is more of a burden on the equipment. In aggregate, when there's lots of connections, it can slow things down. So especially on the public side, we do want to leave that open. So now it's time for our next section. We're going to get our hands on network equipment.